this. Let's move on. So let's say we're dealing with negative 7 over 0. Now that is undefined. That's something you want to memorize. If you divide by 0, you get undefined. I'm going to point out two different ways of kind of looking at this. One is, let's say that if we were dividing by numbers, 8 divided by 4 is 2, and therefore 2 multiplied by 4 is equal to 8. That kind of always works, right? So the way you undo division is multiplication, the way you undo multiplication is division. Fair enough, right? Well, let's try this. Let's say we ask the question of, what is negative 7 divided by 0? Okay, because we're asking this question, what multiplied by a 0 would give me a negative 7? Uh-oh, the pattern kind of breaks down, right? What times 0 is equal to negative 7? Well, it's undefined. That doesn't really work, does it, right? So that's one way of looking at it. Now, conceptually, it also doesn't really make sense to divide something by 0. So, for instance, that's different than the second one. The next one is 0 divided by negative 43, which is just 0. And that pattern still holds in that if I say, well, 0 divided by negative 43 is 0 because 0 multiplied by negative 43 is 0. So algebraically, the pattern holds. This works, this one does not. That's why this is undefined and the other one's not. But conceptually, if I have $0 and I share, let's say we have a business together and we make $0 and we split the profits, $0 profits. We all got $0. You can divide 0. Or maybe we go out to eat and there's just no food, right? Or maybe I have no food but I want to share it with you. Well, I'm going to share 0. Everybody gets 0 pounds of food. We share profits. Everyone gets $0 worth of profit, right? So you can divide 0. 0 divisible actually kind of makes sense. The other one doesn't make sense. It's like, if I had $100 and I shared it among 0 people, what does that even mean conceptually in real life, right? It doesn't really mean much, right? So this is, we call that undefined, right? So again, it's very different saying I'm dividing something by 0 versus that I'm dividing 0 by something, right? Those are two very different concepts. So you must make sure you understand that, right? So those are different. And that technically can be different than no answer, and I'll explain that later when we get there. Okay, so let's move on to a little bit of algebra, right? Okay, so let's say we want to solve. Now what we're going to be doing is we're going to be using two main concepts to solve algebra, and one is something called inverse operation. The other thing is called, we're basically balancing out the equation, right? So, and let's say we have, let's say we take money. Say we both start off with $100. Okay, this is just my own little squirrely example. Now let's say I lose half my money. Well, for us to have an equal amount of money at this point, you also have to lose half your money. So now we have both $50, right? Oh no, that's terrible. We lost half our money. Okay. Now let's say you go and I don't know, you buy a meal for $10, right? Okay. Well now you have $40. Now you have $40. Now for us to continue to have the same amount of money, I would also have to lose $10. So now we have $40 each, right? So now we're back to $40. Yay. Okay. Cool. And let's say we both go to Las Vegas, and I don't know, we go gambling, and you make 10 times as much money. Yay, you win. I don't know anything about gambling, so we're just going to pretend that there's some game we can play where if you win, you get 10 times as much money. And then I have to go over there, and I have to do exactly the same thing. I also have to get 10 times as much money for us to have an equal amount of money. And this is just illustrating the fact that if you start off with an equal amount, right, if one side changes, the other one has to change the exact same way for it to continue to be equal. Well, the same thing happens when you're dealing with variables in that if something happens to one side of the equation, it has to happen to the other side of the equation to maintain the equality, to maintain the fact that they're supposed to be equivalent. So I don't know what the x here is, well yet, but x minus 16 is equal to 7. These are equal. That means that whatever I do to one side, I have to do to the other. Now, the other thing that I'm referring to is inverse operation, which is basically just saying that how do you undo addition? You subtract. How do you undo multiplication? You divide. And then vice versa, right? How do you undo subtraction? You add. How do you undo division? You multiply, right? And then we'll get into some other inverse operations later on. But we're going to use both those concepts, right? Balance whatever you do to one side, we do to the other, and inverse operations. So inverse operations are going to allow us to tear this apart. Let's say I want to isolate or get this x by itself. Well, I'm subtracting 16. Now, I want to undo that subtraction of 16 to get the x by itself. So what I do instead is I add 16. And then I have to balance the equations because they started off equivalent, which means I also have to add 16 to the other side of the equation. That gives me x, right? Subtracting 16, adding 16, those cancel each other out. 7 plus 16 is 23. And then we have a nice little x is equal to 23 there, right? Let's try over here. I want to isolate or get the x by itself, so I have to undo the subtraction of 29. How do I do that? I add 29. But to maintain the equation, I also have to add 29 to the other side. Whatever I do to one side, I do to the other. That gives me x is equal to, I'm adding a negative to a positive. The stronger number is the 64, so I know it's going to be a negative answer. And the difference between these two things is going to be a 39, I think. Okay, so it looks like I get a negative 39. Yeah. Okay. So let's try another one. So again, it doesn't matter which side you get your x's on. It just matters that you isolate and get your x on the one side by itself. So in this case, let's say we want to solve for the x on the right side. That's okay. Now we want to get rid of, undo the addition of 22, and we undo the addition by subtracting 22. And whatever we do to one side, we do to the other. Those 22's cancel out. Negative 7 minus 22 is negative 29. And that leaves me the x. Over here, you have kind of an additional step, and that you want to get all your variables on one side by themselves, all the constants on the other. So we have an x over here, and we have an x over here, and in order to get, we need to get all the x's on one side by themselves. Okay, so what I want to do is I want to get rid of this positive 6x on the left, and the way I get rid of a positive 6x on the left is I subtract 6x. And whatever I do to one side, I do to the other. That gives me negative 8 is equal to 7x minus 6x. Now, I'm not dividing here, I'm subtracting. So just make sure you make sure you know what your notation here means. I know it looks kind of like division, but that's not what I mean here. I'm subtracting, right? And I even wrote it here just to make it clear. Now, 7x minus 6x, if you have like terms, then you just subtract the coefficients. Coefficients are these numbers in front, right? So this is the 7x. The 7 is the coefficient. The next one is minus 6x. 6 is the coefficient. So whenever you have like terms and you're adding and subtracting, you add and subtract the coefficient or the number in front of the variables. So in this case, we're going to say 7 minus 6 is 1, or just x. So we would say negative 8 is equal to x, right? Okay, hopefully that makes sense. Let's try the next one. We have a little bit more involved here because we are dealing with fractions, but it's still the same kind of concept. So in this case, we are going to say 3/5 k plus 15 equals 8/5 k. Well, we still want to get all the k's on one side, so I am going to subtract 3/5 k from each side. So minus 3/5 k minus 3/5 k. These cancel out, and that gives me 15 is equal to, okay, so I'm going to do a little side work here. So we have 8/5 k minus 3/5 k. So we're going to say 8 minus 3 over 5, basically, which gives me a 5 over 5, which gives me a 1. Let's stick back k on there, right? Which gives me k. Right? So we end up with 15 is equal to k. Hopefully that kind of makes sense. Yeah. That's a k, believe it or not, over here. So let me fix that. That looks terrible. Ooh, didn't improve it, did I? Okay, so we'll move on to the next one. Now, what I want to do is I want to get all the variables on one side, all the constants on the other. Okay, so let's say I want to get all my p's. In this case, I want to get all these p's on the other side. So how do I get rid of a negative 7p? I'm going to add 7p. And then whatever I do to one side, I have to do to the other. So these p's are going to cancel out. And that leaves me 8. Negative 6p plus 7p is simply 1p. Right? Negative 6 plus 7 is 1p. Now, there's an implied or understood 1 coefficient when you don't see it. So the point I'm trying to make is p is equal to 1p by default, right? And we're going to get more into exponents later, but the understood or by default exponent is always a 1 too. So if you don't see the coefficient is 1. If you don't see the exponent is 1. Okay, so here we go. And we just bring down whatever's left over. So that's how I got the 5 here, right? Okay, now I want to get all the constants on the other side. So I want to get rid of this positive 8 by subtracting 8. And whatever I do to one side, I do to the other. That gives me p is equal to negative 3. All right, here we go. Let's try to combine like terms before we start doing other stuff. Now, before, we didn't have to combine like terms on the same side. We just immediately started moving things around. But you want to combine like terms first before you start moving things from left to right on the equation. So, for instance, I have a 3t here. And I have a 1t here. That's not understood 1t, because you don't see the coefficient, you understand it's a 1. So 3t plus 1t is 4t. Now we also have a negative 12 plus 2. And negative 12 plus 2 is a negative 10. On the right side, we have a 3t, so just bring it down because there's no more t's here. But we also have a 5, and we have a negative 15. 5 minus 15 is negative 10. Now, let's say we want to get all our variables on one side. Okay, fine, fair enough. I want to get rid of this 3t here. I get rid of a positive 3t by subtracting 3t. And whatever I do to one side, I do to the other. 4t minus 3t is t minus 10. Keep the minus 10 over there. Then I want to get rid of this negative 10 here. Our subtraction 10, the way you do that is you add 10. Whatever you do to one side, you do to the other. Those cancel out. And that gives you t is equal to negative t plus 10, or negative 10 plus 10 is 0. Getting tired, sorry. Okay, now let's say we're bringing into the parentheses. Well, the parentheses are going to do something like this. So you're going to have 3 times 2 is 6. You're going to multiply within the parentheses, just distribute. And then 3 times 5 is 15. And you keep the x. Then minus, you're simply going to flip. You can think of this as a negative 1 times positive 1, in which case it's a negative 1. Or you can think of it as in terms of a negative 1 times a positive 14, in which case you're going to get a negative 14x. Okay, there we go. We keep the 6. Now we combine like terms, so we have a 15x, and we have a negative 14x, which gives me an x. We have a 6, and then we have a minus 1, which gives me a positive 5, and we have 6 here. Next, I want to get the x by itself. We isolate the x. By undoing the plus 5, you undo the plus 5 by subtracting 5. Whatever you do to one side, you do to the other. And it gives me x is equal to 1. And there you go.